Welcome back to Low Stress Math with Mrs. Bono. We are on Unit 7, Transformations, Lesson 5, Dilations, and this is the independent blah, blah, blah. This is the independent practice for rotations and dilations. So let's start with question 1 on page 26. Quadrilateral PQR is plotted on the grid below. Label and graph, and draw the image after a 90 degrees clockwise rotation. And this is where reading is key. Remember, we talked about how clockwise and counterclockwise are completely different directions. And most rotations are counterclockwise, but this one, clockwise. So a 90 degrees clockwise rotation is the same as 270 degree rotation counterclockwise. And if you didn't remember that, you are not alone. A lot of people don't. So let's start by just writing down all of the coordinates. So P, you know what, let's write the general rule. X, Y is going to become, remember, you switch them, and it's going to be Y, and you're going to make the X negative, I think. You know what? I suddenly didn't remember. So let's go back and look all the way back here at a rotation. It's Y negative X. Oh, there, I got scared. Yep, there we go. Always good to double check. So let's see. The P, the original P that is at positive 2, positive 3. And the original Q is at positive 4, positive 3. And R is at 2, 0. And S is at 1, 2. And T is at 2, 3. So I have to start by writing my primes down, because I always seem to forget to do that. P prime, Q prime, R prime, S prime, T prime. And you switch the order. So it's going to be 3, comma, negative 2. You're now remember, that negative X doesn't mean make it negative. It means negate it. That's changed the sign. Luckily, all our signs are positive. But if it was a negative, you would make it positive, because negate means multiply times negative 1. So you're changing the sign to the opposite of what they give you. So we're going to switch these to get 3, negative 4, and 0, negative 2, and 2, negative 1, and 3, negative 2. So switch them and negate the X. Now I can go back and graph what I have. So positive 3, negative 2, P prime. Positive 3, negative 4, Q prime. 0, negative 2 is R prime. 2, negative 1, S prime. And 3, wait, did I mess that up somehow? I feel like I did. P, 3, negative 2, 3, negative 4, 0, negative 2, 2, negative 1, 3, negative 2. I know what I did. I think I put the wrong one on there to start with, because there's no T. I'm a fool. I went back to the original point. It's a quadrilateral, and I made P and T the same thing. See what happens when you're a special sort of child there, Bono. Yep. Made a mistake. Lucky I have whiteout, and I didn't actually graph my mistake. So now it looks pretty good. Now it looks like the original, only kind of tilty. So I am just going to go back And I'm going to use a piece of paper with a right angle on it to double check things. What are you talking about, crazy old woman? I'll show you. I'll show you. Here. Now, to rotate 90 degrees means that, let's say I'm starting with P, and my 90-degree angle is going to start here on O. So that means from P to P prime, I'm a little tiny bit off with my paper here, P to P prime. Here's P, and here is P prime, and there's a 90-degree difference, and it rotated clockwise that way. That's how I know that I did it correctly. I have a 90-degree angle at the origin, and here I am at P, and I went right around to P prime. Now I can check all of my numbers, all of my letters that way. There's S, and it's at a 90-degree angle through the origin to S prime. So it started here at S, and it went to S prime, and look, it went 90 degrees clockwise. They all do that. So this one is correct, labeled it, got all the coordinates. Now it says, what will be the coordinates after a dilation of polygon, blah, 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 using a scale factor of 2. So I have to start with my original, I'm not starting with the original points. I have to start with my primes. So I'm starting with P at 3, -2, and Q prime at 3, -4, and R prime at 0, -2, and S prime at 2, -1. And I have to use a scale factor of 2. Actually, I'm going to highlight that. Here we go. Dilation means multiply, and scale factor of 2 means I'm multiplying by 2. And show your work. Body bah humbug. That means I have to show that I multiplied these things. How do you show that? It's not that bad, honestly. So it's going to go to P double prime, Q double prime, R double prime, and S double prime, and 3 times 2, and -2 times 2. This is me showing my work that I'm multiplying by 2. I think it's kind of silly, but 3 times 2 and -4 times 2, and what is this? 0, -2, and 2, -1, and they all get multiplied by 2. Everybody times 2. Everybody times 2. Oops, forgot to put the 2 there. Look at me, that'd have been wrong. All right, so let's see. 3 times 2 is 6, -2 is -4, so this is going to be 6, -4, and 3 times 2, still 6, -4 times 2, -8, 0, -4, and 2, -1. All right. Oh, this one's going clockwise, very much like the one above it. So given a point for -2 after a rotation clockwise. So I'm going to write the rule down first. Where it was x and y, it's going to become y -x. So if my x and y were 4, -2, it's going to reverse and be -2, and I multiply times -1 to get -4. So there's my new point at -2, -4. All right, next page. Ba-da-da-da. Given this triangle, if the transformation is d 1/4, what are the new vertices? Show your work. Okay, so the scale factor, write that in red. The factor is 1/4. that is the same as divide by 4. So I'm going to take all of these points, S, which is at 4 and negative 8, and I'm going to divide each of these by 4. And K, which is at negative 12, negative 4, and divide those both by 4. And Y, which is at 20 and 16, and I'm going to divide both of those by 4. So multiplying by 1/4 is the same as dividing by 4. So let's see, 4 divided by 4, 1. Negative 8 divided by 4, negative 2. I'll make this a little bigger. It's hard to see like that. Okay, negative 12 divided by 4 is negative 3. Negative 4 divided by 4 is negative 1. 20 divided by 4 is 5. 16 divided by 4 is 4. And there you go. Divide by 4. Which graph shows a 90-degree rotation? From what? What was the original one? A 90-degree rotation from what? Oh, wait, here's the original one. And a 90-degree rotation is going to go this way. And then the bottom of the arrow is going to be here. And the top of the arrow is going to be there. And that's not what that looks like. Or it could be a 90-degree rotation in the opposite direction, which would take the top. I did that wrong. I'm sorry. Yeah, it's my morning, I tell you. Doing a great job here, Bono. Very mediocre. The bottom here is going to go down, so it's going to look like that, going up. So that is correct, because this one is just a slide because it's in the same direction going down, because it's just slid down. So this would be a translation, but that is a rotation. Given the point and its image, determine the scale factor. Okay, remember, it's image over a red. So for these, you have to do image over pre-image. And so what you're going to do is reduce it to lowest terms. So let's do this. 9 over 3. 9, because here's the x, and here's the x. So 9 over 3 is 3. And I'll do this one also. Y over y, 18 over 6. Also 3. So my scale factor here is 3, because both of these numbers were multiplied by 3 to get those numbers. Now this one is going to be a little different. So again, pre-image on top. So negative 1 over negative 2. Well, that's just positive 1/2. And so those were the x's. Now the y's. So you should mark things, Bono. X first, then the y's. So 3 over 6 still reduces down to the same 1/2. So my scale factor is 1/2. All right, what do we have here? Let's do the x's first. Image on top, negative 8. Really? Yes, image on top. Negative 8 over 4 is negative 2. And negative 10 over 5 is still negative 2. Okay, so my scale factor here is negative 2. So you just divide and reduce it to lowest terms. It's image over pre-image. That's the important part here. All right, next page. Oh, look, a graph. I like graphs. Here we go. Graph the sun with coordinates at 5, 1, So let's make this nice and big. 5, 1, 0, 7, and 6, 4. 1, 2, 3, 4. S-U-N. Okay, now I'm going to dilate it by a scale factor of 2. So that means multiply every single one of the, oh, I did not connect them. It said it was a triangle, and I did not connect my points. Bah humbug, Bono. Must remember to do all of it. Here we go. So I'm going to come right back up here, and I am going to multiply everybody times 2. So 2 times 5 and 1. Let's see. 2 times 5 is 10. Oh, can you do that? 2 times 1 is 2. So this new point, S prime, is at 10 too. Well, that's a different way to do it, old woman. Yeah, I know. I do things a little differently sometimes. So this one is 2 times 0 and 7. Let's see. So the U prime is going to be 2 times 0, which is 0, and 2 times 7, which is 14. And the N, it's going to be 2 times 6 and 4. And let's see. So N prime is going to be 2 times 6, which is 12, and 2 times 4, which is 8. So now I have to graph this S prime, U prime, N prime, which I just found, down here on my graph. So not too bad. And like I said, I make this a little bigger so you can see it. The S is at 10, 2. The N is, the U is at 0, 14. Wow, that's really up high, isn't it? And the N is at 12 and 8. Here we go, 12 and 8. And look at how big that got. And that was just with a scale factor of 2. Imagine if we used a bigger scale factor, it'd be even bigger. So there I have the original sun and S prime, U prime, N prime. And if I didn't go back and check it, I'd gotten it wrong, so be careful. Now the next one says triangle SUN is mapped onto triangle S double prime, U double prime, N double prime by a dilation with a scale factor of -1. All that means is to go back to the original coordinates and multiply by -1. Well, you know that multiplying by -1 just changes all the coordinates to the opposite sign. So let's grab a blue pen here, old Bono, and see if we can do that. I got a new package of pens. They're all stuck together. Yada, yada, yada. Here's the blue. Let's go. Please work. So, S double prime is going to be -5, -1. I just multiplied both numbers times -1. U double prime is going to be 0, -7. And N double prime is going to be -6, -4. Just multiply everything by -1. And now when I graph it, it's going to be right over here. But it's going to be the same size as the original because it was -1. So let's try this. -5, -1, S double prime. 0, -7 is U double prime. And -6, -4, which is kind of hard for me to see. Why do I feel like that doesn't look right? -6, -4, negative. Is that right? Could that be? Let me put my glasses on. These little dots are too small for me. I'm sorry, guys. All right. Positive. That's what it is. This is supposed to be here. That should be S double prime because it's 5, and I put my mark at 7. Bad Bono. She can barely read. Look at that. I'm going to erase that. Now it looks right. Now, how did I know it was wrong before I even connected the dots? I double checked to make sure that the two triangles were going to be similar. In other words, they were going to have the same shape. And when I saw that that point was not in the right place, I knew it wasn't similar. I knew it wasn't the same shape. But now these triangles are similar. Well, they're actually congruent, same size, same shape. But because I multiplied by -1, that kind of spun it around and put it in the opposite direction. Hey, wait a second. That dilation of -1 was the same as a rotation of 180 degrees. And by the way, it's also the same as a reflection over the origin. Lots of interesting stuff going on there. I'll talk to you guys soon. Take care. Bye.